can function in many ways, right? If you see, we can say there is a one function called a to b, right? There is one function called a to b, and this we supposed to discuss further. So when function is from a to b, the question is what is the meaning of this? What is the definition of function? So please remember, first of all, because multiple times we will come across with questions like when two parameters are given to us, they will ask how many functions can be made, and if whether it is a function or it is not a function. So you should be knowing definition of function. Have you heard of anywhere the word function before? Function, see, assume the practical scenario, because try to recollect all the given data in terms of practical scenario, so it will be easy for us to remember everything. So if I say, if I am using a TV remote and I'm changing the channels. If I'm changing the channels while using TV remote, and if I press the button to change channel, then definitely it will get changed. So we can definitely say my remote is functioning correctly. So that's how meaning of function came in picture. But assume that if I'm changing my channel, and rather than it is getting changed, it is also increasing the volume of each channel, then definitely we can say in one time two tasks are happening. My channel is also getting my channel is getting changed, as well as a volume is also getting increased. So that's why we can immediately say this is not functioning properly. So that's how this function came in picture. Assume that you want to sleep around 10 p.m. and you want to switch off your light, but when you switch off the light, your light is getting switched off, as well as your fan is also stop rotating. So what you will say, this button, or you can say this switch, is not functioning properly. So that's how the function came in picture. So that's how you supposed to try to recollect all the given data in terms of function and try to put forward. So when it is working properly, then you can say yes, when I have given one input, then we are getting one or desired output, then we can say it is actually functioning properly, otherwise it is not functioning properly. So through this we can decide, or we can infer definition of function. So what, in mathematical way or logical way, we can say what is the definition of function? You can see from your definition of function is, function is a rule, right? Function is a rule that associate, right? Function is a rule that associate every element, right? That associate every element of set A. Assume that there's set A and set B. Of every element of set A with one and only one element of set B, then it is called a function, right? Then it is called a function, and that also we can write down from A to B. And when we say it is from A to B, it means we represent this like from A to B, like this we represent this. So function is a rule that associate every element of set A with one and only one element of set V, then it is called function from A to B. Or in better way we can say, when we give one input, we should be getting only one or desired output, then it is called function, otherwise it is not a function. So function, you understood what the meaning of function. For each and every, right, for each and every input we are having one and only one output, and that's also desired one, then we can say it is function, otherwise it is not a function. So let's take the example of a and b. If I take it is, as I said, function from a to b, just take the example of set a and set b and try to determine this. So assume that in your office there is a vending machine. In that vending machine, numbers are 1 2 3 4 5, and below that options are there: coffee, milk, chai, mango, rum, beer and vodka. These options we are having in our office vending machine. So if you press 1, right, if you press 1, coffee comes out. If you press 2, milk comes out. If you press 3, chai comes out. If you press 4, beer comes out, and finally if you press 5, vodka comes out. So you can see from here, whatever input we are giving, for that we are getting desired output, and that's how we can say our machine is functioning properly, right? Because for each input we are getting one and only one desired output, then is called, which is functioning properly. But assume that, right, assume that there is a scenario when you want chai, right, you are looking for chai in the morning, you press 3, and rather than coming out chai you got rum. Then what will happen? You can say this is not functioning properly, we are not getting desired output. Or it is comes like this: you press 3 and your chai with mix of rum came out, then we can say it is not functioning properly. That means it is not a function. Why is it not a function? Because for one input you should get only one and desired output, then we can say it is functioning properly, otherwise it is not functioning properly. So whatever these inputs are here, whatever the inputs are here, these inputs called domain, right? So these inputs we say domain. And what are the possible outcomes are there, we can say those are codomain. And finally, whatever outputs we are getting, just like a coffee, right, milk, right, coffee, milk, chai, beer and vodka, whatever actual outputs we got, that's called range. So that's how you supposed to understand what is the meaning of domain, what is the meaning of codomain, and what is the meaning of range. So domain is our inputs, codomains are our possible outcomes, and range is our actual outcomes. And so we can say from here, this is a function is equal to y is equal to fx, and this domain we represent by x, and this y, which is fx, we represent by our range. That's how everything's come in picture. See, you can understand through a lot of examples, a lot of functions are possible there, but we will go step by step to see everything in detail, right? When we say, assume that function from a to b, right? When we say function from a to b, and it is given to us y is equal to 2x. So what is x? X we already know, it is called our input, which is domain. So our, if I say our inputs are 1 2 3 4, and what are the possible outcomes? We can say possible outcomes are 2 4 6, because 2x is there, so possible outcomes we can see these are our possible outcomes, right? But if you put these numbers into the function, what outcomes we are getting? We are getting only these outcomes. So whatever this part is here, this part is called range. So you can infer from here, range is always subset of codomain, and this whole part is called codomain, and this part is called domain. So for each image, this also we say image, right? Function is what? For each image we should have one and only one pre-image, then it's called a function. When we will be having more than one pre-image, it is like this. It is also possible case, right? So for every pre-image, there is a one and only one image is possible in the column of codomain, then it is a function, otherwise it is not a function. Let's take an example to understand what are the functions are possible and what are the functions are not possible. So if I take the example of y square is equal to x, so y square is equal to x, is it a function? We can immediately say it is not a function. Y square is equal to x is not a function. The reason behind it, because if I put x equal to 4, put x equal to 4 here, if you put x equal to 4, then this x equal to 4, we can immediately say it can come through when it is plus 2 or it is minus 2. So when inputs, it output is what, plus 4, but output can come through two inputs, plus 2 and minus 2, then it is not definition of function. What is definition of function? The function is a rule associated with every element of set A with only one element of set B. So here you can see every element of set A with one element of set V. So in this case it is not a function, because if I put two input, we comes out to be different outputs. Now you can look into different definitions of function. We can look into first definition. We say function is called one-to-one function, right? This is also function, one-to-one, right? One-to-one function. So what is one-to-one function? For every pre-image there is exactly one image, that's called one-to-one function, right? For every pre-image there is exactly one image, that's called one-to-one function. So we can understand one-to-one function. If pre-images are 1 2 3 and images are 2 4 6, you can see for every pre-image there is exactly one image, and all the elements of set A, this is set A, this is set B, all the elements of set A are associated with one and only one element of set B, then we can say it is a function. So we can see from here, for every, right, for every pre-image there is exactly one image, then it's called one-to-one function. Here if I say fx is equal to x square, is it one-to-one function? If I say fx is equal to x square, is it one-to-one function? Fx equal to x square is not one-to-one function. The reason behind it, because as we have discussed, plus minus 2 when inputs are there, then you can see it will give us plus 4. So this is not one-to-one function, because every element of set A is not associated only one element of one different element of set B. So this is not one-to-one function. So what are the examples of one-to-one function? We can see it comes out to be 2x plus 5 is one-to-one function, because whatever value you will put for x here, you will get only one output for set B or for function. This is called one-to-one function, but this is not one-to-one function. One more thing we can understand from here when we talk about one-to-one function. In one-to-one function, right? In one-to-one function, please remember your codomain, right? Your codomain is always greater than equal to your domain. Right? In one-to-one function, your codomain is always greater than equal to your domain. Why is it so? As we know, if it is a function, then all the elements of set A has to be associated. But it is a possible case, it can come like this also. Assume that we can take one more example here, 8. This is also one-to-one function, because for all the pre-images we are having exactly one image in set B. This is one-to-one function. So here, when codomain is greater than or equal to your domain. Clear? Either it can be equal or it can be greater. If function is not one-to-one function, then we can say other function is called many-to-one function, right? Many-to-one function. If it is not one-to-one function, we can immediately say it comes out to be many-to-one function. Many-to-one function, we can say if these are inputs and outputs are A, B, C, D, and if it is a function, meaning of this set elements, every element of set A has to be associated with set elements of set B. So what exactly a function? All the elements of set A has to be associated with B here. So we can immediately say from here, if this is associated like this is like this is also like this, but here. So what is the definition of many-to-one function? We can immediately say from here, at least one element in codomain with more than one pre-image. So what is many-to-one function? When at least one element of codomain is having more than one pre-image. So here we can say C is having two pre-images. One is 3 and other one is 4. So one element in set V is having more than one pre-image, then that set is called many-to-one function. But you should not be getting confused, right? This is not a function. This is not a function even, right? Here when we are putting 3, we are not getting one output, we are getting two outputs. This is not a function, but this is a function, and this function is called many-one function. So function can be either one-to-one function or function can be many-to-one function. Let's move further and look at the other cases also. Other cases are possible when we talk about onto function, right? When we are looking for onto function. So when you're looking for onto function, so when one function is called onto function, when every image in codomain is having pre-image. Through the definition of function, we know every pre-image supposed to have image, right? It means every element of set A or input should have one image, that means it belongs to in set B. It also other way around here, when every pre-image, this is function definition, every pre-image should have image. But what is onto function? When every image, which is our codomain part, right, which is our codomain part, when every image is having pre-image, then it becomes our onto function. So when this is associated by this, you can see all the elements of set B are associated, or they are having at least one pre-image. So immediately we can say onto function is a function when codomain is or equal to range. So when codomain will become is equal to range, then that function will become onto function. Or we can immediately say, one also think from here, codomain is always less than equal to domain. That you can see also, I have given you example, you can see codomain is always less than equal to domain in this particular case. And one last function is left out. When function is not onto function, this has to be into function. So what is into function? We can immediately say at least one element in codomain without pre-image. It means at least one, when it is 1 2 3 4 is given to us, at least one element has to be here which is without pre-image, then it becomes our into function. So you can see we are not having any pre-image, or we are not having any input for D. In this case it becomes into function. But we are having different names also by which we represent all these functions. So when we talk about onto function we also called surjective function, and this is also surjective function, and into is called non-surjective function. Right. Similarly, if you come back and see one-to-one function is called injective function, and your many-to-one is called non-injective function. So what is one-to-one? One-to-one, when we are having only one image for every pre-image, then it is called one-to-one function. And what is onto function? Onto function, all the elements of this are occupied. This is called our onto function. When you combine both of them, the meaning of this, when you say is one, if the one function is one-to-one, that means when we are having one mapping only, as well as all the elements of codomain are having pre-image, that means it is onto function. In this scenario, when you combine these two functions, there is one more function comes out to be, that's called bijective function. And this is bijective function. So what is bijective function? Bijective function, we know it is combination of injective plus surjective. This is called bijective function. So in bijective function, we know codomain is equal to domain. Right here, codomain will become equal to domain, because all the pre-images we are having, and we are having one-to-one, as well as because of onto, we can say domain also will become equal to range. So in this case we are having codomain is equal to domain is equal to range. In that particular scenario is called bijective function. So let's move further and solve one and two questions based upon this, so you should be having better idea about this. If I say there is a set A. In this set we are having three elements, 1, 2 and 3, and there is a set B. In set B we are having four elements, A, B, C and D, and if we want to make function from A to B, right, my first question, find out one-to-one function. Second question, find out many-to-one function. My third question, find out onto function, and my last question, find out into function. So solve these four questions immediately. number of one-to-one functions, number of onto functions, number of many-to-one functions, like this. Okay, anyway, let's see here. I'm looking for a function from A to B, right? So in A we are having 3 elements. In B we are having 4 elements. See, rather than finding out one to one, many to one, I just want to show you how many functions are there first. Just see how many functions are there. So see, for one, right? One. How many options do we have? One, either I can connect here, or I can connect here, right? Or I can connect here. So like this, we can immediately say for one, we are having 4 options. So we can say 4 options for one. Assume that one I have connected. Can't we connect two there? Yes, definitely we can connect two also there. It is also possible, kid. So for two again we are having 4 options, and finally for three also we are having 4 options. So which comes out to be 64 functions are there. So if I am making functions without any conditions, how many functions can be made? 64 functions can be made. What you're supposed to remember, function will be either one-to-one function or many-to-one function, or function will be either onto function and or one to into function. So one to one function plus, right, one to one function plus many to one function should be equal to 64, which is total number of functions. Similarly, onto function plus into function should be equal to total number of function, which is equal to 64. Now our objective is what? Whether we try to find out how many one-to-one functions are there, or we can find out how many many-to-one functions are there. And through the concept we already know, finding out one-to-one is easy task rather than finding out many-to-one function. Because if I'm looking for one-to-one function, we have to look for one-on-one mapping. So now look at this one. If I'm looking for one-to-one function, how many different options we are having for this one? Only 4 options. Only 4 options. Either this one will get connected with A, B, C, or D. So only 4 options we are having for this one. But when this one will get connected with any one of them, for two, how many options we are having? I cannot connect two with A because we are looking for one-to-one function. So for two we are having only 3 options. So for two we are having 3 options, and similarly for three we are having only 2 options. So how many one-to-one functions can be made? We can immediately say we can make 24 one-to-one functions. So how many one-to-one functions can be made here? 24 one-to-one functions can be made, and one-to-one plus many-to-one should be equal to 64. Then how many many-to-one can be made? 40 many-to-one functions can be made. So 24 plus 40 is equal to 64. So total number of the function which we can make is equal to 64. Similarly, if I am looking for onto functions, right, you understood, answer for the first question is 24, second question is 40. Now, not 40, 64, yeah, 40, right? Now look at the onto function. So onto function, we already know what is onto function, right? I'm looking for onto function here because onto plus into is equal to total number of functions. So onto function, when domain is, right, domain is greater than equal to codomain and codomain is equal to range, which is called onto functions. So onto functions, we know these are the 4 elements, right, and these are the 3 elements, and these 4, all of them will get associated with previous one, right? So ultimately question comes out to be, right, see, just try to recall it. Let's try to recall it to make it easy. What is onto? All the elements of this set should have pre-image. And what is function? All the elements of this should have image. That means they are saying these both of them should be occupied. This they are saying all the elements of set A and all the elements of set B has to be occupied. Now when all the elements of set B has to be occupied, we are having four elements, and these four elements we have to, right, four elements we have to distribute among three places, because pre-image has only three places. Such a way not a single pre-image is unoccupied, right? Every pre-image should be associated. That's how function came in picture. So we can say in how many ways these four elements or these four people you can put in these three boxes, right? I can change the question: how many ways these four balls can you put in these three boxes, so that each box should have at least one ball. So when each box should have at least one ball, we can say only one case is there. One of them will be having two balls, other one is having one ball, and last one is also having one ball. Only these ways are there. We can put all these in this particular boxes. So let's look at how can you do it, right? Let's look at how can you do it onto function. So this can be done in how many ways? We can see from here. This, out of four balls, we can choose any two ball we can put here, right? Then how many balls are left out? Only two balls are, or see what you're supposed to understand. I will show it to you, right? Again, only two balls are left out, so two you can choose. Out of two you can choose one of them and put here, and finally one left out, choose one of them and put here. Now but these balls can be arranged, right? Is a possible case two can come here, one can come, and like this it can be arranged. So how many ways it can be arranged? We know one will come here, so we can arrange in factorial 3 divided by factorial 2 ways, so which comes out to be 4 into 2 into 3. It 4c2, 4 into 3 by 2, sorry, 4c2 is 6 into 2 into 3, which comes out to be 36. So how many onto functions can be made? 36 onto functions can be made. So we can see from here we got onto 36 onto functions can be made, and into we can immediately find out 64 minus 36 is equal to into functions. Right, how many onto functions we got? So total are 64 functions are there. 64 minus 36, it comes out to be onto function, which comes out to be how much? You can see it comes out to be 28 functions are there. So 60 36 onto functions can be made, and 28 into functions can be made here. Let's take one more example to move further and solve these questions. I hope you understood now. If I change the question, assume that element set A is having four elements A, B, C, and D, and set B is having three elements X, Y, and Z. Question number one to one. How many one to one can be made? Question number two. How many to one can be made? Question number 3, how many onto can be made? And finally question number 4, how many into can be made? Please solve this question. So see here, see when I did this, right? I'm just giving you, just look at, first of all, just see this, and then I will give the example of that, right? One to one can be make one to one when there are four elements A, B, C, D, and there are three elements X, Y, Z. One to one is not possible. If we cannot do one to one. So how many one to one functions are here? Is equal to 0. How many many to one functions are here? That means whatever functions are left out, all of them are many to one functions. So for A, we are having three options. For B, we are having three options. For C, we are having three options, and for D also we are having three options, which comes out to be 3 to the power 4, which is equal to 81. Now onto is possible here, but onto was not possible in previous case. Just see here, when I did this, when I see two elements are here, one element is here and one element is here, at that time you would have asked question, if I'm associating two elements with one element, it is not a function even. That you did not ask question. When I'm associating two elements with one element, it is not a function even. So what exactly I have done, this is the case is possible when you are having four elements here, and in this scenario you are having four elements here and three elements here. Then it is possible because these two can go to 1 and remaining can go to 1. Then this case is possible, otherwise this case is not possible, other way around. So 36, which answer we got for this particular function. So here onto functions comes out to be 36 and into comes out to be 81 minus 36, which is equal to 45. These are the right answer for this particular case. But if you look at previous case, right answers comes out to be 0 and 64, right? So right answer for the previous question are 24 for 1 to 1, 40 for many to 1, 0 for on to, and 64 for into. Why? Because if I'm distributing 4 into 3, you can see if I'm 4 into 3, this is not a function even, so we cannot consider this is function. But in this scenario, when you are having four elements in set A, right? In set A, when you are having four elements, in set B you are having three elements, then definitely you can connect like this. So 4 you have to distribute in 3 and you have to make sure everyone is connected. That's why everyone should get at least 1. So answer comes out to be 36. Right answer for this question is this. Let's move further. 1 and 2 things are left out. Now look at what is called, for cat point of view, it is not very much important because it comes only once in 2013. After they did not ask questions based upon bijective functions. So look at the inverse function. Inverse function has appeared multiple times. That is important one for cat point of view. At inverse function, if I am looking for inverse function, if I say y is equal to 2x, so function is what, when 2 you will put increase 4, again you will put increase 8, again you will put increase 16 is going on. Inverse, it comes other way around, 16 will become 8, 8 will become 4, and 4 will become 2. That's how inverse function goes. So in this case, inverse function will become x by 2. And how will you be doing it? When you are looking for the inverse function, you can see from here, in the place of x you can put y, in the place of y you can put x. So here we can say x comes out to be 2y, so y comes out to be x by 2. That's inverse function of this. So we will solve few questions based upon this. So whenever you are looking for the inverse function, please remember your domain and range will also change, right? when you're looking for the inverse function, your domain and range will also change according to the function and vice versa. I can show it to you. Assume that the one function is called fx is equal to x. What is domain? Domain can be any, right? Domain can be any real number. And what is range? Range also can be any real number. But if I say fx is given to us x square by x, so when x is given to x square by x, our domain will change. I cannot put r is equal to 0 because it is not defined. So real numbers minus 0 and range is also real numbers minus 0. But if I say fx is given to some particular constant, then you can say your domain will remain all the real numbers. You can put whatever you want, but your output will remain constant only, which is k. Similarly, if I say our fx is given to us mod x by x, in this case I cannot put r is equal to 0 because it will make 0 by 0 form, which is not defined. But your range will remain 1 and minus 1 and 1. And only two values are possible, either minus 1 or 1. If you're putting x as a negative, it will come minus 1. If x is positive, it will come 1. And finally, when fx is given to us x divided by 2x plus 3, in this case, what is your domain? We cannot put 2x plus 3 cannot be equal to 0. So we can say from here x cannot be equal to minus 3 by 2. So when x cannot be equal to minus 3 by 2, we can say from here our domain comes out to be range minus 3 by 2. And range, to find out the range of this function, you have to, because range we cannot find out here through all the what number we supposed to put, so we will get range there. I cannot do that because you have to look for 0 1 2 and all the negative numbers except minus 3 by 2. So what we supposed to do here, we have to use inverse function. That's how inverse function came in picture, right? Inverse function if we use, and whatever domain will come for inverse function, that will be range for this particular function. So how will you get the inverse function of this? We know in the place of x we can put y there, so 2y plus 3, so it comes out to be, we can take one side, it comes out to be 2xy plus 3x is equal to y. So we can see y we can take common from here if we take that side, so it comes out to be 1 minus 2x, y is equal to 3x, so y comes out to be 3x divided by 1 minus 2x. Now you got the range because 1 minus 2x cannot be equal to 0, right? So we can say from here that means x cannot be equal to 1 by 2. So x cannot equal to 1 by 2, so range of this function comes out to be a real number minus 1 by 2. That's the range of this function, and that's the domain of this function. That's how range and domain came in particular picture, right? So why don't you guys, other functions are useless completely when we talk about the even function and odd functions. Those functions are not even worth of discussing, even though it will not come. What is even function? When fx is equal to f of minus x, this become even function. Example of this we already know, it is x square. And what is odd function? When f of minus x is equal to minus f of minus x, this is odd function. When we say fx is equal to x cube, this is an odd function, this is an even function. Now come back to your sheet and solve questions from sheet. It will be, I have compiled a good number of questions from the sheet, so it will be easy for you to get the idea about what types of the questions generally you will come across while writing your paper. So algebra 4, arrange and all you can try out. Why don't you try out question number 5 here? Try out question number 5 and question number 6, both the questions 5 and 6. This we can write on 15 minus x square minus 2x is greater than equal to 0. So x square plus 2x minus 15 less than equal to 0. So we can see from it comes out to be x plus 5 and x minus 3 should be less than equal to 0. So it comes out to be x is always less than equal to, or if you see over number line, x will lie between minus 5 and plus 3. X will lie between minus 5 and plus 3, which is answer option B for Bangalore. For question number 5. Look at question number 6 here. In question number 6, it is given to us y is equal to 1 upon root 9 minus x square. So under a square root, it has to be greater than equal to 0. So it has to be not equal to 0 even, because 0 form is not defined. So 9 minus x square has to be greater than 0. So which we can write down x square minus 9 has to be less than 0, which is x plus 3 into x minus 3 has to be less than 0. So it comes out to be x has to be greater than minus 3 and x has to be less than 3, because over number line if you put minus 3 and 3 it will lie between that. So answer for this question, answer option C for California. So all of you got the right answer for these questions. So let's try out 2-3 more questions before we will move towards another topic. So why don't you try out question number 10 and question number 11? Both of them are CAT questions, question number 10 and question number 11. At composite function, when we say f of gx, right, when f of gx, it is always equal to, we know, g of x, right? This is called composite function. So questions based upon this can be good questions, right? G of x, they can also write down this function also like this, g of f of x, which comes out to be g of fx. Right, so these are the composite functions. We will solve one question based upon this, which has come multiple times in a competitive examination. That's a question number gx. This particular question number 20, you can try out 20, right? Question number 20, which is 20, you can try out. It's a repeat cat question multiple times. Sorry, it has come in paper. Question number 20. Okay, so let's discuss this question also. It is given to us g of x plus 1 plus g of x minus 1 is equal to gx, right? This also we can write on the place of x, we can put here x plus 1. In the place of x, when we'll put here x plus 1, then see, first of all, this also we can convert in better way. We can write down g of x plus 1 is equal to g of x minus g of x minus 1. Now in the place of x, you can put there x plus 1. So if you put x plus 1, wait, give me 1 second. See, put right on here. Put x is equal to x plus 1. So when you do that, x is equal to x plus 1. G of x plus 1, g of x minus is equal to gx. Okay, so put x equal to x plus 1. So we can immediately say from here, it comes out to be g of x plus 2, right? And that number I have taken that side, so which comes out to be g of x plus 1 minus g of x, right? This we can write down immediately. Now when you write down this, try to compare this with previous numbers, right? If you compare with the previous, then you can see this and this got cancelled, as well as this and this got cancelled. So from here we can immediately say it comes out to be g of x plus 2 is equal to minus g of, because if you add this, it comes out to be g of x minus 1 is equal to 0, right? So from here we can say g of x plus 2 is equal to g of x minus 1. So now in the place of x, we can again put x plus 1. So it comes out to be g of x plus 3 is equal to minus g of x. Now you can compare with your question, because question is looking for x plus p. G of x plus p is equal to minus g of x. So from here p comes out to be 3. So we can immediately mark answer 3. That's the right answer. Clear? Not only this, but also you can look, because if you see this question, you can solve in multiple ways. When it is given to us g of x plus 1 is equal to g of x into g of x minus 1, you can look into what exactly is given to us. When we say first two numbers are 1 and 2, what is third number? Third number of this series will be difference of previous two numbers. So 2 minus 1, which comes out to be 1. Again, next number will be 1 minus 2, which comes out to be minus 1. Again, it comes out to be minus 2. Again, it comes out to be plus 1, right? Because minus 2 minus minus 1, so which comes out to be minus 1. And like this is going on. So when you are looking at, if I say this is given to us g of x plus 1, right, then we can immediately say this comes out to be, right, this number which is minus 1, this comes out to be g of x plus 4, right? And this comes out to be g of x plus 2, then this comes out to be g of x plus 5. So what exactly I'm trying to say here, see, when this number, if I say it comes out to be g of x plus 2, we know this number will become g of x plus 5, right? But what is negative? Is negative. So when this is 2, then this is 5, then we are looking for difference only. 5 minus 2 is equal to 3, because when this number will become g of x, then this number will become 3. So answer comes out to be 3 here. The question is based upon actually series here. So I hope you understood function properly. So your task is what to solve the remaining questions from the sheet. So but before ending this class, I just want to discuss algebra 5, some basics, so you can try out a maximum number of the questions from the sheet itself. Right, in the sheet is combining all possible questions which you will come across based upon AP, GP and HP. And basics of AP, GP, HP most of you already know. We know when we are looking for AP, GP and HP, and we are looking for when AP is given to us. AP we know when common difference is constant, when first term is A, second term is a plus D, third term is A plus 2D and A plus 3D, and up to so on it is going on. So like this we can look for the nth term also, which comes out to be A plus n minus 1 into D. Similarly, summation, if you're looking for summation, we know n by 2, which is and then first term plus last term, which is A plus n minus 1 into D. So summation of terms comes out to be n by 2, which is 2a plus n minus 1 into D, the summation of n terms. But when series is given to us infinite and looking for the summation of infinite series, it comes out to be a divided by 1 minus r, where r has to be right less than, right, modulus r will lie like this, right, 1 minus r, because I cannot write down here a upon r minus 1 and r is greater than 1, then the answer is comes out to be infinite. You cannot find out if series is given to us like this 2, 4, 6, 8 and up to so on, and they're looking for the summation of this series till infinite. We know when series is increasing, then summation will be infinite. So for these kind of the questions we can find out some when series has to be decreasing series or series has to be fixed. If it is infinite, then we have to look into series has to be decreasing series here. 8, 4, 2, 1 up to so on is going on. Is for AP, so I'm successful, you already know it. Sorry, this is for AP till here. Right? Till here it is for AP. This particular scenario. Below that I'm discussing GP. Right? Till here it is AP, and if you're looking for summation or nth term in a GP, you have to do only one parameter. In the place of plus sign, put the product sign, so a into, in the place of product put power there, 1 minus r. This becomes your GP. This is AP, this is GP, but in the place of D we use r here, right? Similarly you can look this particular part also, right? So when we are looking for summation of GP, when number of terms are fixed here, so we already know it, a into 1 minus r to the power n divided by 1 minus r, and infinite is given to us, then a upon 1 minus r. So the basic formula you already know. So but what types of the questions generally you will come across? Questions like this: from a top we have dropped one ball, right? From top of a height of 500 meters we have dropped one ball, and this ball goes back only 2/5, right? 2/5 it goes back and come back. So 2/5 it goes back up, that means it is 200, it goes back and then it come back, then again 2/5 goes back and come back, and again 2/5 and again 2/5, then it's going on like this. So find out the total distance covered by ball and when ball will come to rest. So 2/5, that means 200, then again 2/5, then again up to so on like this. So when first term here, how will you do this question? 500, then 2/5 comes out to be 200, but 200 it will cover while going up as well as while coming back. So and again it's going on, right? Plus 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 up to so on is going on, right? But r is given to us 2 by 5. Then we can see it comes out to be 500, and summation of this series we can find out when a divided by 1 minus r, and that's the right answer of this particular question. When ball will come to rest, how much distance ball will cover? Into 2 has to be here, right? Into 2 has to be here because this distance has covered 2 times. So what your task is, what for tomorrow's, before tomorrow's class, please try out as many as questions possible from this sheet. Also we will discuss this sheet as well as we will discuss new concept, right? Because what questions you will come across in your paper, those questions can be based upon sigma n, sigma of sigma n, or sigma n square, and once I have also seen questions like this. So most of the time questions will be like this, right? Other questions you already know. See, these kind of the questions I'm not discussing, you already know when we're looking for summation of this kind of the series, right? 4 you can take common, multiply by and divide by 100, and like that you can do it. Multiply by 9 and divide by 100, like this you can do it, right? So this I will discuss in tomorrow's class, but before this please try to complete this algebra 5 sheet. Right, so thanks a lot. Try to solve a function as well as the algebra 5 sheet. So see you tomorrow at the same time. We will discuss modulus as well as we will solve questions from algebra 5. So thanks a lot.